Hi everybody, welcome to a new Python tutorial. In the last two tutorials we learned the difference between threads and processes and how we can use the built-in threading module. In this video we will go into more detail about the multiprocessing module. So we will quickly recap how we can create and start multiple processes. Then we will learn how we can share data between processes, and we will recap how to use logs to prevent race conditions and how to use queues. And at the end we will learn how to use a process pool to easily manage multiple processes. So let's start and let's quickly recap from the last video how to create and start processes. So we say from multiprocessing import process, and then down here we define a number of processes. So a typical good choice for this is the number of processes on your machine, and you get this with os.cpu count. And then you create your different processes with process equals process. And this takes a target as a function argument, and the target is a callable function. That is then executed by this process. So we define a function up here. This simply squares some numbers. And then we give this to our process here. And then for each process we call process.start and also process.join. So this says that we want to wait for all processes to finish and block the main program until all these processes are done. So this is all we need to set up multiprocessing. And now let's go into more detail. And first let's talk about how we can share data between processes. So in the last video with multi-threading we learned that we can easily share data between threads with a global variable. And now with processes, processes don't live in the same memory space, so they don't have access to the same public data, and because of that they need special shared memory objects to share data. And there are two shared memory objects that we can use. We can use a value for a single value, or we can use an array. So we say from multiprocessing import value and import array. And down here let's first start with a single shared value. So we say shared number, and this is now a value. And this takes two arguments. First we have to give it the data type as a string, so we give it an I for integer and a starting value. This is now 0. And first of all print this, so we say number at beginning is, and then we say we access this shared number with, or this value with shared number dot value. So now if we run this, then we see that this is 0. And now let's create two processes that should modify this number. So we say process1 equals process, and as a target it gets a function that we call add 100. So let's define this up here. So let's define add 100, and this gets a number. And then it should modify this number a couple of times. So we say for I in range 100. So 100 times it should say number dot value plus equals 1. So it should increase this by 1. And we also want to modify a behavior that takes some time. So we say time dot sleep and 0.01. And so here we give it this add 100 to our process, and it also needs arguments. So we say args equals, and this is a tuple. So here we give it the shared number, and be careful, since this is a tuple with one element, it also needs a comma here so that Python knows that this is a tuple. And then we create a second process that will do the same thing. So process 2 that should add 100 to our shared variable. And then we say process 1.start and process 2.start, and then we wait for them to complete. So process 1.join and process 2.join. And now at the end we again print our number, so we say number at end is, and then access it with shared number dot value. So let's execute this and see what happens. So at the beginning is 100, it's 0, and now we got lucky. Now let's run this a second time. And now it's not 200, so it's only 168. And why is that? Because here a race condition happened, and I will not explain this in detail, so please have a look at the previous video. There I explained in detail how race conditions occur. So a race condition occurs when two threads or processes try to access and modify the same shared variable at the same time. So in this case, both processes try to read and write into this object at the same time. So some operations might get lost here. So in this case, it's only 168. And to prevent this, we must use a lock. So we say from multiprocessing import lock. And I also talked about this in the last video, so please check this out. So a lock prevents another process from accessing this at the same time. So to use this, we create a lock object. So we say lock equals lock, and then we give this to our function. Yes. So this now also takes a lock. And a lock has two important methods. So first we say lock.acquire, and then at the end we say lock.release. So as soon as we say lock.acquire, it will set this in a locked state. So this means that while this is running, no other process has access to this code and can execute this part here. And then when we unlock the state again with lock.release, then the second process can also execute this. So this is all we need to prevent multiple processes to modify this at the same time. So now let's run this. And now we get 200. Let's run this again. And yeah, it's still working. And a better way to use locks is to use locks as a context manager. So whenever you say lock acquire, you always have to call locked release then at the end. Otherwise this will block and your program cannot continue. So don't forget this. And you can use a lock as a context manager. So we say with lock colon and then your code. So this automatically will acquire and release this for you. So yeah, this also works. And now this is how we can share a single value. And now let's share a array. So we say shared array equals array. And this also needs a data type. So in this case, let's give it a D for double. And here give it a list as initial values. So we say put in 0.0 here, 100.0 and 200.0. And then we say our array at the beginning is, and let's say shared array. And then we have to access each element with inside brackets and then with the index. And we can also use slicing here to access all indices. So let's just put in a colon here. And then again print this at the end. So at the end we want to print our array. So array at the end is this. And now we have to change our function. So this now takes multiple elements, so this takes numbers. And then we have to go over each number here and increase it. So first of all, let's also change this parameter here. So let's say shared array. And now in our function, what we want to do is we want to go over each number and increase it, but be careful here. So we cannot say for number in numbers and then simply say number plus equals 1. So now if we run this, this will print our array at the beginning and at the end, and this is still the same. And this is because this loop here will create a local variable called number that is then increased. So this has nothing to do with our shared value object. So in order to do this, we have to say for, and let's say for I in range, and then the range has the length of our array, and then we access each element with numbers dot I and say plus equals 1. And now let's run this, and now we see that it got modified, but we also had race conditions here, so don't forget the lock. So we say with lock and then our modification operation, and now we increased each element in our array by 200. So this is how we can use the shared value and shared array, and we can also use a queue to exchange elements between processes, and I also already showed this in the last video. So a queue can be used for process safe data exchanges, and so in the last video we said from queue import queue, and there we have to use a slightly different queue that is from the multiprocessing module. So this has all the same methods except the task done and the task and the join method. So a queue is a linear data structure that follows the first in, first out principle. So the first element that you put into your queue, that is then also the first element that gets retrieved when you want to get elements. So let's make an example to use a queue and exchange data between multiple processes. So in this case, let's say queue equals queue, and then create two processes that should access and write to this queue. So we have a process that gets as a target, it gets a function that we call square, and as args it gets some numbers and our queue. And then we create a second process that has a second different function here. So we call this make negative, and it has the same arguments. So it will write to the same queue. And now let's define our functions here. So we say def square, and this will get some numbers and a queue. And then we say, so in this case for I in numbers, we calculate the square and put it into our queue with queue.put I times I, and then a second function make negative, and there it also takes some numbers and a queue, And here we also go over our numbers for I in numbers, and then we say Q dot put -1 times I, and then let's start our processes. So process 1 dot start and process 2 dot start, and then process 1 dot join and process 2 dot join. And here we don't have to call q dot join because there is no method q dot join. But what we can do is we say while our queue is not empty, so while not q dot empty, and then we want to print each element, so print q dot get. So this will return and also remove the first element in our queue. And yeah, now let's run this and see what happens. Numbers is not defined. Oh, sorry, I have to create a numbers variable, and I will say this is a range object from 1 to 5. So, or 5 should be included, so I say from 1 to 6. And now this will print each element, and we see that both processes have access to this queue and can write or put elements into it, and then in our main process we can also access the queue and get the elements back. So this is how we can use a queue. And now as a last thing, let's talk about a process pool. So a process pool can be used to manage multiple processes. So a process pool object controls a pool of worker processes to which jobs can be submitted, and it can manage the available processors for you and split, for example, data into smaller chunks, which can then be processed in parallel by different processes. So let's have an example how this works. Basically, a pool takes care of a lot of things for you. So you don't have to consider a lot. So we simply say from processing import pool, and then down here we create a pool, and we say pool equals pool, and then it has it has 4 important methods that you have to know. For the rest, I would recommend to have a look at the documentation, because there are a lot of more methods, but the most important ones are map, apply, join, and close. So what we want to do is we want to create multiple processes that should access or execute a function. So we define a function cube, and this takes a number and returns the cube. So it will return number times number times number. And now here we can simply say, or we create some numbers. So numbers equals a range object from 0 to 10 or only to 9. And then we say pool dot map, and now we map, we have to give it a function, so we give it the cube and the numbers, and this will return a result that we can then print. So print our result, but first of all we have to, so this will, what this will do, this will automatically allocate the maximum number of available processors for you and create different processes. So typically this will create as many processes as you have cores on your machine, and then it will split this iterable into equal sized chunks and submit this to this function, and this function is now executed in parallel by different processors or by different processes. So this is all you need to write, and then the pool will take care of the rest. So this will allocate the pools, it will split the data, and then run this method in parallel. And when it is done, it will return the result, and we have to call pool.close, and then we can call pool.join. So this means that we want to wait for the pool to process all the calculations and return the results. And we have to remember that we should call pool.close before. So now if we run this, we can print our result, and we can see that it has the cube here. So yeah, this is how we can easily use the pool to run different processes with a function. And if we simply want to have one function executed by a pool, then we can say pool.apply, and then also the cube, and then in this case it will only has one number here, so we can, for example, say apply numbers, the first element, so number 0. So this will execute a process with this function with one argument. Yeah, so this is the most important things about pools. And there are also asynchronous calls to this map and apply functions, but I will not cover them here. And yeah, for now that's all I wanted to show you about the multiprocessing module. I hope you enjoyed this tutorial and now feel comfortable working with multiple threads and processes. And see you in the next tutorial, where we'll learn about function arguments and parameter passing in Python.